Hello, welcome back. In this video, as I said, we will be doing the resistance, the identification of which normally we will have many bacteria with plasmids. In some bacteria, in some bacteria there will be plasmids. In some bacteria we won't have plasmids. The plasmid will not have code inside, and while in some bacteria the plasmid will be inside, but the gene we require, which is over here, the gene for coding insulin, the gene for coding insulin, it is not there. It is not coded. It is not inserted inside. So what do we do in such a case? We have this test. Normally our plasmids which we used are called PB322. This one contains the resistance for tetracycline and ampicillin. So if we have our cells like this, if we keep ampicillin, what does that mean? If we keep ampicillin here, almost all the this way ampicillin will kill this one, right? So this is out. So this will be out. It will die. Now there is another thing. Ampicillin. Now ampicillin is the one that determines the difference between not ampicillin, tetracycline. Now when this, for the second test, we keep tetracycline, right? Tetracycline. So this is not J, this is T. Tetracycline. Now when we keep tetracycline, what happens is only those with the transformed, with the inserted gene, look here, it says the tetracycline gene is cut using this enzyme. This enzyme cuts here, right? So we cut by this PAM high. The insulin gene was inserted. Bacteria with this modified plasmid are no longer resistant to tetracycline. So when the insulin gene is inserted, these are no longer resistant to tetracycline. So they can be affected by bacteria with this modified plasmid are no longer resistant to tetracycline. But normally the plasmid will be resistant. So what we do is, when we keep this tetracycline, some of the plasmids will die. Now in our case we won't have such distinct cases. We'll have like groups. Like maybe we'll have this area, then there will be this another area, and there will be another, then there will be another area, and this one won't have just one, it will have like billions and billions of bacteria. So in most cases, if one bacteria is taking up the insulin, if one of the plasmid is taking up the insulin successfully, then there are chances that most of them around it will be taken. So if we take a sample over here and check it out, if it dies with by using bacteria, then we're gonna take the bacteria from that group. So we need to be careful here. So there are many bacteria here, right? So when we see that a bacterium is affected, then we can know by tetracycline, then we can know that that bacteria is the one we have to take for our case. And that is the resistant bacteria testing. Which bacteria are we supposed to be taking? Here it says the bacteria were then grown on agar jelly containing antibiotic. Those with plasmids containing the insulin gene grew on the plates with ampicillins but were killed on plates with tetracyclines. You see, so those with plasmids, they were killed on ampicillin, they were killed on tetracycline. So we can know that if we keep tetracycline, if this one dies, then we have to take his partners, and we have to go and test for this one, okay? Because we need only the one which have this insulin gene inserted in the plasmid is the only one which can be required for our process, right? So after this we will be continuing with our video in the previous page. Hope this was clear.